Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to take a look at partial fraction decomposition, where you have a quadratic factor in the denominator that has an exponent other than 1. And the first step is we're going to have one fraction that has x squared plus 1 in its denominator, and a second one that has x squared plus 1 squared. Now, because these factors are quadratic, the numerator has to have that form, ax plus b, and in the second one we'll do the same thing but with two new constants, cx plus d. Now, when we multiply through by the common denominator, we're left with the numerator from the left-hand side, x cubed plus 2x squared plus x plus 5. On the right-hand side, we'll have ax plus b times x squared plus 1 plus cx plus d, and that's it. The question you should ask yourself right here is, do I want to do this the easy way or the hard way? And I'm going to tell you the easy way. I tried to record this video 3 times the hard way, and here's all the work, right, starting here, and I made an arithmetic mistake in the middle. It killed me. And it took a long time. So I'm going to show you an easier way to get this done that's going to be give you a better chance for getting it right. Save some time and a better chance for getting it right. That's a winning equation. What I need to do is expand the right-hand side. And I'm going to have an x cubed term, an x squared, an x, and a constant term. And I'll just set those coefficients equal to the coefficients on the left-hand side. And it's going to solve pretty nicely. Hear me now, believe me in a moment. Ax plus b times x squared plus 1. We want to use FOIL-style multiplication. Ax times x squared is ax cubed. Ax times 1, that's plus ax. Distribute the b, that's plus bx squared. And b times 1 is just plus b. Nothing to multiply, so just copy down plus cx plus d. And this is still equal to x cubed plus 2x squared plus x plus 5. On the right-hand side, there's only one cubed term, so that's ax cubed. I'm going to just draw a line through it so I know that I've used that one already. There's only one squared term also. That's bx squared. There are two terms that have x. Ax plus cx I can write as a plus c times x. And then finally two constant terms, b plus d. We copy down the left-hand side one last time. And what I know is that the x cubed terms have to be the same. So I can start with the coefficient for x cubed on the right, a, is equal to the coefficient for x cubed on the left, 1. I've got one of my values, a equals 1. So far, so good. For x squared, the coefficient on the right, b, is equal to the coefficient on the left, 2. That's 2 solutions. So far, so good. For the x term, the coefficient on the right is a plus c. That's equal to the coefficient on the left, 1. I already know that a is equal to 1. So if I substitute that in for a, I get 1 plus c equals 1. Subtract 1 from both sides, c equals 0. That's 3. 1 to go. This is the constant term. And on the right-hand side, we've got b plus d. That's the term without any variable x. On the right-hand side, that's equal to 5. Well, I know from above that b is equal to 2. So I can put in 2 for b. 2 plus d equals 5. Subtract the 2, and I get d equals 3. That's all 4. That was pretty nice. So I can put in 1 for a, 2 for b, 0 for c, and 3 for d. So again, this was ax plus b over x squared plus 1 plus cx plus d over x squared plus 1 squared. And now bring in those values. So 1x plus 2, we can just write that as x plus 2 plus c was 0, so that term disappears, and we're left with 3 over x squared plus 1 squared. Pretty neat, huh? All right, so there's the partial fraction decomposition, an example where we had a repeated quadratic factor in the denominator. That's it for this section. I'll see you in the next section.